So here we are, we've got our first string all done. They're all wired in series. There are 9 cells. Each of them is about a half a volt. So when you add them all together, we're looking at about 4.5 volts here. But we want to make sure to check it with the multimeter just to make sure. And also each cell is between 3 and 3.5 amps. So that should remain constant. Remember, when you put cells in series, you're adding the voltage, but the current stays the same. It's only when you parallel them that the current rises. So we've got our testing block here. I'm going to go ahead and slide it underneath the first panel. And what I want to make sure is that I kind of slide it up enough that it's going to be resting flush on there. So got that. I will turn my multimeter onto the volt setting. And I've got my first contact here. Take my second one. So that's good. We know that the series connection should be good. And just to make sure that the cells are working properly, I'm going to go ahead and set this to off. Flip this over to the amp. Flip it back over here. Do the exact same thing. You should take a little bit more care when you're measuring the amps than the volts to avoid shading the cells, because that will affect the output reading of the current. So we're looking at about 2.2 amps, which, considering the clouds that are in the sky right now, we're over 60% of optimal, and I would say we're only at about 50% of sunshine. So I'm feeling pretty good that this string is good. So I feel confident enough that I will go ahead and start wiring my next string. And of course, after I get 4, we're done soldering them together and we'll move on to the next step. Okay, so now we're actually securing the cells to the substrate, and here's that silicone tube that I was talking about that is essentially permanently flexible, which is really good because of the thermal expansion that goes on inside the cells on almost a daily basis. So all it takes is just a little dab onto the cell. So I'm going to start up at the top, work my way down, and then I will go ahead and pull the string up and flip it over. And you don't need very much. Just a tiny little tab, tiny little glob. It's just like that. And now you want to grab the top, pull it up, and I went ahead and made the marker so that I know where to put that first panel at. It's pretty nice, pretty important to get that first panel down good, because then the rest will just fall right into place. Again, you want to make sure your hands are really clean before you do this, but you want to give just a little pressure right into the middle of the cells. You can see how it kind of moves around a little bit. That's it, just kind of working down into it. And so you do that, and you kind of, after you're done, want to make sure that everything's lined up. It looks good to the next row, and it's pretty straight and uniform. And because the way that the tabs are with that little indentation, you've got a little bit more flexibility to work with, so you can kind of move it around a little bit. So you essentially do that all the way up, and after we finish this string, we'll have all 4 down, and we'll be ready to wire the series together. Okay, so now we've got what resembles a panel. We've flipped them over, we've laid them down, and they're actually connected now to the substrate. However, I did leave this one, as an example, unconnected. So what we're looking at is the power coming in here, and instead of it just being one long row of 36, it goes through here and around. So essentially, we need to connect these two, and these two in series to provide that same circuit and leave it unbroken. Well, how do we do that? Because when we wire the panels together, one end has no soldering tabs. The other end has the 2 sticking out, here and here. Well, what I've done, and I like to use this knife to lift up the cells because it's very thin and you can get underneath of them very well. I left this one available so I could flip it up to show you. Just take another piece of the tab ribbon and just solder it to the back so that it comes off the bottom of the cell, so it's a positive lead. So now you've got a lead coming off the bottom of this one, which is positive, and the lead's coming off the top of this one, which is negative. Well, what we do is we connect these together. That creates a series circuit, and it keeps the panel moving in that continuous flow. Because remember, you want that continuous flow to flow all the way through the panel, and in order to achieve that, we need to connect the strings together. So we'll go ahead and we'll prep some wire for this. And again, I prefer stranded over bare copper just because it's a little bit more flexible and easier to work with. But you know, you can use some more of the tab ribbon, or thicker bus ribbon would work as well. You know, but I just happen to have some wire, so you know, that's what I'm going to work with. It'll work just fine. So let's go ahead and get the copper wire out and start prepping that. Okay, now I've grabbed this copper here, and we're essentially going to be taking this. We're going to start on this end of the panel and work over. This is the negative lead coming in, so we're going to be using red for negative and white for positive. You know, ideally it's good to kind of stay uniform with what you're using, but you can really use any color for anything. I like to keep white as positive because that's kind of recognized. If someone were to stumble upon it and see a white wire, they would assume it was positive. So we're going to basically be measuring from this point to that point, and that's where we're going to kind of cut into it so that there's bare copper, and then we're going to stretch it over. This is where our two wires are going to leave the panel out the back, and that's where they're going to be, you know, providing energy outside of the main panel box. So to start off, what we're going to do is we're just going to very carefully mark from here to where we're going to need to cut this. And instead of a pencil, I'm using a pen because it shows up better on this. Pencil actually doesn't show up at all. So now that you've got that, I'd like to take that knife again that was good for lifting up the solar cells and just kind of go just about, I don't know, 1/8 an inch, maybe 1/4 inch on either side, and just kind of work with it and cut around. And this kind of requires a little versatility. If you want to go ahead and use the wire cutters, you can, but I actually feel that these knives do it a little bit quicker. So I just cut a nice round loop on either side, and then I cut kind of in between them. And just like that. You've got a little spot here where the tab will connect to it. And then I will take this, we're looking at 14 gauge, so you fit it into the 14 gauge hole. And make sure that the knife, when you're done with it, you close it up. And then just kind of run this around. And then make sure that you're kind of far away from the solder gun, which is on right now, and from the cells. And just get a nice grip and pull it off. That strips the insulation off. And from here, we have got the two connections. And then I'd like to run this to basically where we're going to build that hole, where we're going to drill the hole in. And then I just like to make a nice angle, because I want this to stay as flush as possible. So I want a nice tight angle so it'll just be able to go right into that hole. So from this step, we're essentially taking the wire, and one important thing to keep in mind is that you want to keep it far enough above the top of the cell so that you can connect these two. So you want to allow enough space for another wire to go in between the cells. So once you're up here, you can use that knife again to get up underneath the tabs. You can see this one a little bit better. So I like to really wrap it around to make a nice connection so that when you let go, it won't really move anywhere. The hard part is done. So now you just take the soldering gun and then basically just apply a little pressure downward and just go ahead and lay the solder on there. Now you've got a solid connection. So we'll go back with more silicone and actually secure them down. But now this is our negative home run, as I call it before, and it will be going through this hole when we have it, and then you'll have this length of wire coming out the back of the panel, and we'll strip this end, and then we'll have an open spot to work with.